slide in
See your desktop, yes.
and now my slide, I hope.
Yes, and presentation
Perfect.
mode.
Good. Thank you very much. It's a pleasure and honor for me to be here today and to present this project. I'm coordinator of TwinEU. TwinEU is a project that was funded under the call towards a digital twin of the European electrical infrastructure. Let me anticipate that it's a young project. We just started, so I don't have much about results. My scope today is to give you an overview of the goals and the objective that we have and the vision that is behind the project, so much as some of the use cases that we plan to cover. And for me, I mean, as you will see, it's quite relevant to be in touch with you guys and this task force, because the aim, as said, of this project is to establish a European level standard that can be applied to the whole infrastructure, the whole electrical infrastructure. Sorry, there is a background noise. Maybe somebody has the microphone on. If you could.
Yeah, if you could please go on mute, I appreciate it. Thank you.
Thank you. So, as I was saying, it's a task of the European Commission to develop a solution that could be actually deployed. So it's not just research, is with a clear application goal. So stay in touch with the relevant activity as yours is critical to build consensus, be aligned. So be happy also in the future to have exchange with the task force, or with find a way for the project to be not an independent entity, but something that is aligned with the general community. Just to give you an idea what the project, some numbers, we have been funded under the Horizon European Innovation Action. So Innovation Action is a project, European Commission, with a quite high level TRL. So basically, when we reach the end of the project, we should be very close to commercial product. That's a distinction with the so-called research innovation action, which are more basic research. So this is supposed to be an activity that brings very close to real world. And the topic was supporting development of a digital twin to improve management, operation, and resilience of the EU electricity system in support to Repower EU. For those of you not living in Europe, Repower EU is a piece of legislation, European Commission, that was written after the start of the war in Ukraine, in which Europe started defining a vision for the energy system that is independent from fossil fuels from Russia, which determine, big questions, also resiliency of our infrastructure and so on. As I said, it's a young project. We started in January 2024. We are planned to operate for 36 months. We receive basically 20 million euro from the European Commission. The companies are supposed to chip in, so the total budget is in the range of 25 million euro. As you see from the map, it's a gigantic consortium. I had the pleasure to work with more than 70 partners in defining, and then you can really see this European level ambition. Is not something that will affect one or two countries in the EU, but one way or another, basically every European country is somehow European in sense of EU. Basically all of them, not 100%, but close to, are involved in this activity at different level. And among those, particularly active are transmission and distribution system operators, and in all basically those countries. Let me start with a sentence straight out of our project application, but I think it's the best way to say what we want to do in these 3 years. TwinEU will leverage a unique set of competences coming from grid and market operators, technology providers, and research center to create a concept of pan-European digital twin based on the federation of local twins, so to enable a reliable, resilient, and safe operation of the infrastructure while facilitating new business models that will accelerate the deployment of renewables energy sources in Europe. What is really important in this sentence is what is in bold, basically. The key point is we are talking about a federation of local twins. So We don't aim are saying this is the digital twin of Europe, but we are aiming at defining mechanisms with which efforts that are already running in the different member states of the European Union can be aligned, make them interoperable with each other so that the global picture may emerge. So there isn't one magic place where TwinEU will be running in the future, but we are talking about federation of data, a federation of models that will enable this global continental better picture. Behind the view of the Commission, this digital twin is not only for the operation of the grid, but also, as mentioned here again in bold, to enable new business models, new idea that can emerge by the availability of this large model. And of course, the bottom line, which is also in line with the Repower EU, which set goals of penetration of renewables by 2030. The purpose at the end of the day is to accelerate the deployment of renewable energy resources. Again, here, a list of challenges. So why, when we sat together with this long list of partners, we thought, what are the challenges that we want to tackle in the project? Where do we see that there is need of innovation to bring a vision of a continental digital twin to reality? I like to say, starting what was very clear, sitting together with distribution system operator and transmission system operator, there is a lack of consensus and definition. What is that we really call digital twin? What are the minimum set of functionality to claim that a grid is equipped with a digital twin? So this is let me say, a little bit of fundamental work we want to achieve. A lot of the methods that we have been seeing, so let's say the starting point of the digital twin of the partners look like solutions which are not properly synchronized with the reality. So how this process should be enabled, what is, again, minimal requirement to say that a twin is really twinning reality is another important fundamental exercise we want to complete. There is a lack of something that we can bring to the European level. So people have been working in Europe on their own network with a very limited horizon, let's say. And that brings the problem of interoperability of modeling, for example, as one topic we want to tackle. But in general, what is an interoperable digital twin? So that cross cooperation among the different operators can be actuated. That means, but also important that with the higher penetration of renewables, the electrical grid will be under, as you know very well, a lot of pressure, and it will rely for the resiliency also on other element of energy sectors, other element be even outside the energy sector. And so it's critical to link the digital twin to a bigger effort that is running in Europe, which is the development of a European energy data space. We don't plan to just develop theoretically or to run in the lab. We plan very real, concrete use cases in the real network. And I will give you some example of those towards the end of the presentation. And of course, we don't claim that this project will solve all the problem in the world. The objective, we are already operating right now in the direction to define a lot of scenarios. So where the digital twin can bring an advantage, particularly our focus is always in this intra-data and cross countries, given as assumption that the different grid operator, particular transmission level, are already running some form of twinning. But we think that the interactions and the extension down to the distribution all the way to the low voltage is a critical element, particularly in relation to the penetration of renewable. To achieve that, we aim at developing and implementing a reference architecture. I'll have a screenshot of the vision of that in a forthcoming slide. And this will bring, this is the philosophy of the architecture, to a federated structure. So there will be several instances running in the different countries, in the different operators. So there will be more instances in a single country, but they all being able to talk to each other to reach the European level solution. To make this possible, we see need of work in data models and semantic to enhance the interoperability. And we need to break data silos, and that's connected to the problem already mentioned before. And the idea is because things has to be pushed to the limit of technology we have today to be a research project. We will look at also the role of advanced technology like artificial intelligence, high performance computing to go beyond the classical modeling approach that's been tested so far. We will develop and deploy a set of services that, as I will show you later, in the different countries, the focus will be on different use cases or different scenarios. And that will allow us to try the idea and the technology under very different conditions. And we want to then create the condition to go beyond the project. As we know, one of the major issues in this large initiative, you have funding for 3 years, then the project is over, and there is always a risk that a big amount of work get lost. And that's not the case that we want here. So we envision already mechanism, and we can talk about it, to support the work also in the future. So the project will not continue with a 20 million euro funding, of course, but will find a way to be financed also beyond the support of the European Commission. And in a summary, that brings to a set of key innovation that we aim in the next 3 years. An open solution, one point I didn't stress enough, it's part of the strategy of the European Commission and perfectly aligned with the strategy of the project. Everything new that we will develop, particularly at the level of federation and interaction with digital twin, will be open source so that everything we develop can be shared in the community. That's one key point where we can talk about cooperation in the future. We plan to to address data and model interoperability. So we plan to propose extension to available standards. We will have running federated digital twin infrastructure. We will have running the link and the adaptation to data space so that this data sharing going beyond the grid operator. We want to have closed loop adaptive digital twin, including immersive metaverses options. Again, I'll show you an example in that direction in one of the use cases towards the end of my presentation. Here a view of what I anticipated several times, the architecture. You can see different layers. As I mentioned, we don't aim at one single digital twin, but to a federation of digital twin. So when we were putting together the consortium, we contact a long list of grid operators, and we learn about the effort that was already going. Those are the, let's say, building blocks that you see on the lower layer of digital twin that we bring, that we cluster and federate. Why these two levels? One, because there is a tighter connection at the national level, particularly between DSO and TSO. And then there is a need of federation at continental level. Going up, we get into the 3 big technology challenges, which are model sharing, data sharing governance, data integration and homogenizations. And here you see reference, for example, to some of standard and infrastructure that will be the foundation. Of course, common information model is one of the key standards when it comes to data modeling for the exercise we want to do. SAREF is another important ontology that has been developed in European projects before. And then you see towards the left more computing related and cloud related standard like GaiaX and Fiverr, which are, again, open solutions available in Europe. And then we go up in the level of data sharings and model sharings. And at the top, we have the service workbench. So what are the common services that the federation will offer to the different partner of the network? And then last but not least, the possibility of third-party access so that the digital twin is something that with proper data connector will be available also for connection from parties which are not grid operator, and that's where the innovation in business model is expected to come. In building this process, we, as I mentioned also in the introduction, we build the solution on top of previous experiences. And the most relevant for this project is another large project, which again I had the pleasure to coordinate, called OneNet. OneNet was another large project running for 3 years. Focus was on the link between TSO, DSO, and customers for the purpose of enabling European level market of flexibility. And what is relevant from that previous experience was already there the idea not to enforce solutions from the top, so from the European level down to the different operator, but to support a process of coordination and federation. In that purpose, we developed a concept, which is the OneNet connector, which is represented in the architecture here. The OneNet connector is a data space type of connector, so coherent with the standard developed by the International Data Standard Association, Data Space, associations, but specifically developed for the energy sector, starting from flexibility, but here in TwinEU will be extended with other use cases. But in any case, OneNet connector is the only, at the moment, data space connector which has energy in mind. So for us will be the key element also for the federation of the digital twin, as it has been the technology supporting the federation of platforms in implementing new models of flexibility at European level in OneNet. In OneNet, this was implemented using the centralized approach. So the OneNet, again, is not a single platform sitting in one place, but is a decentralized middleware based on peer-to-peer connection through the data connector. So while the previous picture gave a logical view, which is a classical multi-layer IT solutions, is vice versa, completely distributed deployment. And that architecture principle, so the idea to have participants, a network of platform, and then a framework. So these 3 layers will be basically one-to-one replicated with the principle of the digital twin, but not now focusing on flexibility market. As I said, in this purpose, the OneNet connector is the key piece of solutions that was developed. And the OneNet connector has been now released as an open source tool, will become a project. Well, I mean, we applied to the Linux Foundation Energy to become a project so that the OneNet connector can be adopted from all the grid operator in Europe. But in principle, there is no reason why it should be limited to Europe, and facilitate data interchange among operator, but also operators and customers, or operators and third party, as I mentioned, critical for new business models related to digital twin. I don't expect you to go through everything written here. Here, just they want to give an impression, let's say. What you see on the top are the countries listed that will actually participate in the physical implementation of the digital twin in TwinEU. And wherever a country is mentioned means that basically we have at least one TSO, one DSO involved in each of the different 8 demonstrators that you see listed here. Some cases we have even more than just one directly in one countries. And then you see in the left, in the center of the slide towards the left, the list of functions, and correspondingly the dot tells you if that function will be present in one of those 8 different demos. And so as you see, there is a long list of functionalities that we plan to have available and to have running in real scenario. I collected from our partners some of those examples This one comes from the Italian demo coordinated by Enel, but in cooperation also with Terna, which is the transmission system operator, and also with Areti, which is a distribution system operator in the region of Rome. So here is one of the most complex ecosystem we have in the demo, because we have 3 operators from Italy involved, plus other actors like NLX, which is the market player. So that's an example of third party involved. Then, of course, we have some research institution like a network of universities and RSC, the large research lab in Italy. Here is where we go also in the direction of metaverse. So it's not only modeling in the sense of electrical equations, but also linked to the building information models, and so possibility to analyze extension and development of the infrastructure before placing them. And so creating a virtual behavior simulation of in a realistic scenarios for pre-qualification. And this is part of effort with a lot of technology under development in Enel, in e-distribuzione, in supporting this advanced picture of a digital twin. We have another example still coming from the Italian demo. I picked some of the demos where I thought were somehow interesting for this discussion. In this case, it's about the defense systems. So we are dealing with using, and this is not only done in Italy, but will be done also in the Dutch demonstrator, using real-time simulations as a way to analyze, so hardware-in-the-loop technologies as an example of implementation of digital twin to assess defense logic, looking at power system stability, security, and to use this testing and methodology to prevent major events and blackout. The German demonstrators, vice versa, involve 1 transmission system operator. Germany, we have 4. In this case, Amprion is the one participating. And then we have 1 distribution, one of the biggest distribution system operator, which is Westnetz, which is part of the E.ON group. They work together with one company that is a daughter company of E.ON, which is called Envelio, which is leading at the end the technical development in this case. And then we had the cooperation with some research institutions like TU Dortmund, my own university, and Fraunhofer, where I'm involved, that will participate together. And here the tasks are related to 3 pillars, basically, of application of the digital twin. One is dynamic grid monitoring, so extending the concept of monitoring that is currently available, particularly with focus on the effort, in this case, for the distribution system operator, which plans to get to a much more detailed vision for respect to the monitoring of the grid. We have an end-to-end flexibility. In Germany, we have an ongoing program of implementation of flexibility solution. There are different generation of program called redispatch. Right now, we are running in real life the 2.0, but there is different generations that will be implemented, requiring more and more data exchange between TSO and DSO. So that's a good example of this interaction between different operators. And last but not least, the application of the digital twin in the area of net planning and connection requests. That's one of the best examples to see the role of digital twin in supporting and accelerating the deployment of renewable energy resources in Europe. This other case comes from Slovenia. They are picked this one because we have, again, dynamic assessment, a static analysis from the point of view of dynamic stabilities. But here, their goal is to assess also the role of AI-driven algorithm that will provide the solution for the contingency situations. And this will be mostly focused on the transmission level. And that's the leader for this reason is LS, which is the transmission system operator in the Slovenian country. Another example here is about virtual sensor for transmission line monitoring. This is happening in Hungary, vice versa. And also here is another case where the digital twin will rely on the application of artificial intelligence, in particular artificial neural network, that will be used for defining and implementing virtual sensors. And again, an example of study related to stability, this case in the Dutch network. The Dutch network is one of the network under more pressure right now in Europe because the very rapid deployment of renewables together with a very quick uptake of electric vehicles is at the moment definitely the network more under stress. For that reason, the grid operator in the Netherlands particularly sensitive to the stability and security of operation of their infrastructure. Yeah, that brings me to the conclusion. I try to give you a view of this quite project with quite high ambition and complexity. We want to have a real impact. As I said, we are in, according to terminology of the European Commission, we are in innovation action, so we are supposed to come very close to the final product, so industrial level. We have a strategy to go beyond the funding period, and that's because, as I say, everything will be open source, will be released as open source. And we plan to link our work to two different institutions supporting this activity. One is a Federation of Industry to support research in this field, which is called CRESIM, which has been originally launched by the grid operator in France, RTE, but is now becoming a quite large European institution with several grid operator participating, but it's not limited only to grid operator. We also have now industry joining. It's a forum basically of create project funded by industry and work in cooperation with the set of research center in Europe. And together, CRESIM is like the new development, worked very close with the Linux Foundation Energy, so that at the end, new technology are developing in the project, picked up by CRESIM, bring them to the right level of maturity where they're not, and when they're industrial level, they can be managed by community in an open source approach by the Linux Foundation Energy. So that's also our vision on how this project will survive, let me say, the 3 years funding, and where we hope to have a concrete impact on the European infrastructure in the upcoming years. With that, I thank you for your attention and be happy to have discussion with you guys and answer your question. Thank you very much for your attention.
Thank you very much, Professor Monti. It was very informative, and I'm sure you're going to get a lot of questions. Before I open the floor for questions from the audience, a quick question from myself. It was in the news in December 2022, there was an agreement or some sort of interaction between ENTSO-E and EU DSO to create a continental digital twin for the whole Europe. Is this work related to that, or is it a consequence of that agreement, or these are parallel, separate efforts?
It's a little bit of everything of what you said. So the agreement and this project are both coming from the initiative of the European Commission. So the European Commission wants to have this European level digital twin. So they push the two associations to talk to each other, and they set up the funding to develop whatever technology is not there yet to make it happen. As part of our project, we plan and we have in the description of work to stay in contact with this committee. And of course, basically 80% of my partners are also involved in the other effort because they are grid operators. So there is a natural link, but within the consortium, we have a special committee that is in charge of continuous communication with the two entities. And myself, for example, I have a meeting next week with the UDSO because we need to continue aligned. So they're not the same thing because that's it's not a research or an innovation action. They want to come to concrete agreements, but of course the agreement should be based on the results of our project and vice versa.
Got it. Got it. Thank you. All right. So questions from the audience, please feel free to come off the mute, or if you have any question, if you're more comfortable, put in the chat. I'm going to read it for you. So I see one question from Sanjeev. He is saying, great presentation, Anto. Would you please elaborate more on challenges while implementing TSO, DSO interaction techniques through digital twin in OneNet project?
In the OneNet or in the TwinEU?
In the Sanjeev, maybe you want to clarify, you mean in this new project or in the OneNet project?
Yeah, I think I'm referring to the OneNet project. So that is already completed and you have a lot of lessons learned. So we'd like to know more on those challenges.
Yeah, in the OneNet, the OneNet project focus was on flexibility market and creating flexibility solutions. So we addressed two things there. On one end, starting from a lot of experience in previous project and in real life, we harmonized a set of market products for flexibility. We defined then correspondingly the profiles, and we mapped those products to specific data exchange that are supported by the OneNet connector. I would say the challenge is that, it's, let's say, the typical European situation. So member states go their own way at the beginning. Then comes a point we need to try to build solutions that are European. And so a lot of work is about harmonizing, first of all, on the product, and then in the data exchange. The Commission has the ambition to make sure that everybody that wants to participate to a market can do it independently from the location in Europe, so that whatever you have as an asset, you are always under the same condition, no matter where you are in the continent. And so OneNet had the task to make that happen, starting from a fragmented situation in terms of market definition and everything as we had 3 years ago. And I think we went quite ahead in that. And there are a lot of, I think, personally, very relevant results. I invite you to visit the website of the OneNet. A lot of the deliverable can be downloaded, you can read. And quite proud, for example, that the Finnish market will release soon a call for tenders for the implementation of the flexibility market in Finland. And in the requirement, they wrote directly, you have to use the OneNet architecture. So that shows that they believe in what you have done, and the level of maturity is such that, you can put it in a tender and ask people, please go and use it.
Yeah, thanks a lot. I mean, that's a great outcome of the OneNet. And just follow up. The question is like, how did you realize this digital twin? Did you use the offline modeling softwares to really represent the system models, or did you use a real time for the markets? I mean, the market is completely different. So, but if you want to realize the system level, so how did you represent them in those scenarios?
As I try to explain, we don't enforce one solution. We facilitate the federation of the different solutions so that different operator may offer a digital twin in different format. The ambition will be as much as possible to have it in real time and available all the time. But this is a very long shot. So I think this will come quite for sure at the transmission level. At distribution, I think not that much, or at least not everywhere, and not with the same level of details. But the infrastructure will be there. As I say, this is the first large project of the European Commission, and we set the options down to make it happen, and then this has to go on for several years after the duration of the 3 years of funding. And that's why I said also in my conclusion, the funding, the condition to make it survive, it's very relevant. So there's 20 million euro of taxpayers are not lost in 3 years.
Yeah, thank you.
Farzad, please go ahead.
Sure. Thank you for the great presentation, Dr. Amant. My name is Farzad from University of Louisiana. I heard a lot about this project, and it was a pleasure to learn more from someone who is directly involved in this project. So I wanted to ask you about the main motivation, because this is a big project, like a multi-million-dollar project, right? This is what I'm assuming. What is the main motivation? What you expect to improve the most at the end of the project? Is it like testing new technologies in the future, or decision making during emergencies, or what?
And it will be, as I try to show with the examples, different country by country. So the different grid operators set their own priorities. What is more critical for Italy? What is more critical for Spain? What is more critical for France? So the different use of the infrastructure will be different in the different countries. And all of the one you mentioned are present, maybe in one country, not in another one. I would say resiliency is the number one priority, probably the one that pops up more often. There is a lot of concern about resiliency in Europe, one end because of the transformation we are going through, quite aggressive approach to penetration renewables with this repower view. I mean, the war in Ukraine pushed us to accelerate the process, but that's also a challenge from the electrical perspective. And so that's one of the things. At the same time, with the climate change, and we have more and more extreme weather. I spent many years in the US before, and you are in Louisiana, so you know very well what is hurricanes and so on. I grew up in Europe, we never heard. Now we have hurricanes. That's.
I didn't know that. I thought no
they have a funny name, but they're happening in the Mediterranean. See, they're not as bad as the one you get in the ocean, but they are called something like Medicane, I think, something to say it's a special version of the Mediterranean, but really extreme weather we never had before. Wow. And that's, we have a lot of stress on the infrastructure because of extreme weather, which was not the case in Europe, 10 years ago.
It seems we have enough hurricanes now. We are exporting some hurricanes to European countries. So, Dr. Monti, that's not a technical question. Are you willing to host a group of students, faculty from our universities at RWTH, maybe in the summertime?
Yeah, sure. It's a pleasure.
Okay, so we can learn more about, because from this project, it seems that Europe is ahead of us. So we wanted to leverage expertise, and because the doctor was saying, please correct me if I'm wrong, we don't have a large scale digital twinning project in the US, right? At the moment.
An implementation of a digital twin no, we don't have it yet.
So. Yeah.
There's some work happening in progress, but not a complete product yet.
Yeah. But Hossein, they just gave an award to NREL, remember? Mm-hmm. I sent you the link. So their NREL is getting old. I mean, who knows really, because there's so many projects in U.S. national labs that, but these typical U.S. national lab projects, the results are, you can't really use them half of the time. So I wouldn't know, but I know that there's one out there that NREL got. So.
Yeah, I thought.
But you're right. We are in the US. We're at least 10 years behind. Just interoperability of models. What Europe has done with SIM for steady state, they have 52 or more companies exchanging data. Dynamics and EMT is a whole other mess, but Europe is at least 10 years ahead, and I don't think we can catch up if we continue with the way that we do things here.
Yeah, I thought Farzad's question was about completed projects, right? Was that the question?
Not necessarily, because I see TwinEU is a really big project with a good number of countries involved. So I don't think we have a project at the same scale in the US with
similar thing in the US.
Involved.
Yeah, but I would say this is the construction like Horizon Europe is. As I was 8 years in the US, there isn't anything like that forces those international cooperation that would be intrastate cooperation in the US at that scale as Horizon Europe. So it's a very specific condition of funding that we have in Europe that makes this possible. So yeah, it's a good thing to have Horizon Europe. That's the point.
Awesome. But thank you so much. Anyway, I learned a lot. Appreciate all the information you gave us.
My pleasure. And like I said, I'm more than happy to stay in contact. So this is, I think we all have to learn from each other. So, and for me, whatever is developed, if we have consensus and everything becomes more usable, at the end, there is nothing that has to be European. The network electrons are the same in the US. So we could learn from each other and come to common tools, so there is no barrier of closure from our side.
Anto, there's another question from Jean Belanger, which is actually related to the same that Luigi just mentioned. So he's thanking you for your good and high-level presentation, and he's asking if the standard to share the EMT model data is now settled. What's the status, if you are aware?
I wouldn't say settled, but yeah, of course, as was mentioned, common information model will be a starting point because that's a standard already used with the CGMS, which is the standard profiles defined by NTSOE, the Association of Transmission System Operator. But as I said, that's part of the work to be done is to expand, because as Luigi was saying, that's a static model. And here we need to go beyond the static model. And that's part of the work that will be developed within the project. So this is part of the innovation we want to bring. So it's not settled. It's settled the starting point, which is the CGMES of European transmission system operators, but that's not sufficient, as Luigi was also saying.
Yeah.
And again, this is a point where cooperation is great. I mean, if you have a similar effort going on, will be definitely relevant to stay in touch. And at the end, my view is that if we come to solutions that we develop together as an open source, then they become a standard. And so that's the process that I think we should follow.
Thank you. I'm going to ask another question while audience are going to put their questions in the chat. Whom do you think, Anto, will be, or whom do you envision to be the end user of this digital twin? So do you think the main user, the end user will be like the operator or the planner or the protection engineers or the market operators, or maybe all of them?
I would say all of them, because all the use cases I showed that will be demonstrated are focused on the point of view of the grid operator, for sure, because they are the one doing the project. But the view of the commission is broader than this. And the idea is just give an example of some of the envision application for the future. If I'm a developer of a large renewable power plant and I have to decide where I'm gonna place my, I don't know, PV farm, right now, I have one of the big issue is, do I have the grid connection, and where is the best place for my grid connection? So it would be fantastic if I have a way to simulate that I'm installing somewhere in Europe, and then I take my decision because I realize, oh, the grid there is very good for my connection. So while I develop the plant, I know I can connect. And right now this is difficult, and it's an uncertainty in the planning that large investors have to face. So the idea is that having a possibility for a third party, as I had in my examples, to interact with this digital twin should facilitate investment, for example, from large renewable plants in particular.
Yeah, makes sense. Any other question from the audience?
I mean, if I could ask some more, I don't know if I'm allowed. Well, I didn't ask any, so.
It's your first one.
Anto, I don't know if you remember, but many years ago when I was in Europe, I really was pushing really hard to get within the CGMS to have Modelica. as a way of mapping the equations, and there are some ways to have IP protection for that. So you can't. I mean, the software will be able to see the equations, but not the people, right? So I thought it was useful, but I'm not sure. When I saw CGMS, the newer versions, they're adding other ways to have these more detailed models for dynamics. I don't know where the EMT part is. So I'm wondering if I'm just wasting my time continuing trying to push for being able to do model translations between SIM or PSSC, because PSSC is what they use in the US, 1/3 of the US interconnections. Or am I wasting my time, or is still of some value? I know that it might be of no value in the US, but is it still some value elsewhere? This is more on the topic of, we have to build all of this tooling to be able to have models to integrate. And this, to me, that this was the other solution. So that's what I'm trying to see. If I'm going in the wrong direction, I should stop, but I won't do it at this point, but at least know how to sell it better or what to do to go forward. Yeah. And I mean, I'm aware that you guys are working on that too, so I follow.
Yeah, you're preaching to the choir.
No, but
totally...
more with a critical eye that I don't have it because I'm deep in the mud there, right?
Yeah, but no, I personally agree with you. This will be to the best of my knowledge, the best option. I think some of the operators are in line with that because RTE, for example, has been working on this tool called Dynavo, and they do the same. So they use Modelica as a way to specify. And to me, we don't have an alternative to Modelica to have powerful language to define models. So personally, I will be in favor. We will be successful in this approach. There will be part of the hard discussion in the project because there will be probably different views, I can imagine.
Yeah, because that's why I'm wondering, because I mean, RTE is really unique. I mean, there's no other TSO with that I know of with the manpower, the funding, and the infrastructure to build what they're building.
Yeah.
And I mean, I'm trying to think while I talk, and I'm not very good at it. I apologize. But what I'm seeing is that, I mean, it's very challenging otherwise to convince other utilities, especially in the US. I mean, it's very challenging.
In this respect, this concept of data space. So the data space connectors are a very interesting concept because allow you to share data, controlling what you share. So that may help because you may decide what you share with whom and for what purpose. And that's intrinsically in the protocol. And that's where you can go over some of the hurdle of concern and fear in some of these issues. So that's where my hope is, that through the data connectors, in the data space logic, we can find an agreement on what can be shared and how, and the rules of sharing so that those concerns are removed.
Right. Okay, so it's the concerns that you are seeing is more on the security and privacy and access control.
Yeah.
How about non-technical concerns? I mean, of the type of anthropological, sociological, it not developed here, or it's not PSSC sort of a mentality.
Don't know. That could be probably.
Or it's not RTDS or mentality too.
Don't know. That probably would be part of the question.
Also. I mean, because that's really the barrier that I'm seeing, that we could be doing a lot, especially for, there's an IEEE task where they're trying to specify how you should build the models that include source code. And to be quite honest, you could just have wrapped an FMI to have a common interface between all the tools, but they build their own interface. And I am now trying to implement a C interface in Modelica to adjust that. So we have layered standards now. So this is my major challenge. I've been trying for more than 10 years to address these sociological or anthropological issues, and I have no idea how this could be resolved. Because in Europe, you have the power of the law that is saying you have to exchange data and you have to do it in an interoperable way. But elsewhere, we don't have the power of the law.
Okay.
And it comes to those problems. Do
Yeah.
you have a solution for me or for
No.
others?
No,
No?
I don't have a
Okay.
magic solution to anthropological question.
That's even
All
more
right, sorry,
difficult.
I took over so many questions, but I
No,
haven't
it was
seen
a
Andrew.
pleasure. Thank you, Luigi.
We have, I think, 4 minutes left. This might be the last question from Philip. So he says, great presentation, Anto. Thank you. I was wondering if you could expand on how do you envision the adaptive digital twin instances will work and how they will be adapted. Also, once the project reaches its ends, its fundings, what is the plan to continue having this federated digital twin alive?
So for the adaptation, I can say, well, what we are working on in my group, but this will be very specific. We are looking at using measurement to continuously adapt the estimation of parameters in the system. And we are looking at different methods to do that. We had just recently had a publication also, I think, at the PS. So this the direction we, as a Gaussian process, where from a mathematical perspective, what we are doing. So that's what we also plan to investigate here. And we are already doing it in a German project. But probably other digital twin will do it differently. So there can be different methods that will be tested in the project. But related to the continuation, there will be two different aspects. For some of the operator, I say these are real use cases, so they will do it because it's part of their business. And the project should bring those products to a level that for them makes sense to continue. But there will be work to be done for the research and the innovation. That's what we want to do in the CRESIM Association, where the different utilities can put money and we create pot of money for projects, which is already running. We have a budget of more than 1 million euro per year, where we do these coordinated efforts with the utilities. And then also the idea when everything that is mature enough will continue in the Linux Foundation Energy. And I also imagine, because of the activity you mentioned in the first question, this DSO, TSO task force, some of those requirements will become as legislation in Europe, that you have to have available certain type of data exchange to support. So the grid operator will be enforced by law. That's somehow what Luigi was also saying, that's typical of European Union, to have certain interfaces available, and that will guarantee that things will survive.
Very good. Okay, I think this takes us to top of the hour. Antonella, I really appreciate your presentation and the time you spent with us today. And I hope we can have you in the next calls as well, be part of the group. Thank you. And thank you everyone for attending this session. So our next one will be on May, I don't remember the exact date, but I think it's the second Thursday. I think it's 9th of May. And as usual, I will send out the introduction of the presenter as well as the presentation topic a few days before. All right. Thank you, everyone.
Thank
Have
you.
a nice rest of your day.
me.
Bye-bye. Thank you.
Bye-bye.